Morning YouTube. I'm back again with another video. This one though, slightly different. This is going to be my last video ever as an Ideal Boilers engineer. It's quite sad really. I'm having to leave because of health problems. I can't fulfill my duties anymore. So by the time this video comes out, this van will have gone and I'll be no longer employed by Ideal. Whilst I'm doing this, I'd probably like to thank everybody at Ideal for the graciousness they've shown me. It's been a great experience. I've loved everybody, and every hour that I've worked for them is a great company, and I'm going to miss everybody dearly. Now that's over, I'm going to talk about diverter valves, or in this case stepper motors, which are these things here. Diverter valves have taken many forms in the past. They've been hydraulic diverter valves where they've used water pressure to move a diaphragm. Then we went to the motorized big head, which looked a bit like a three-port valve. Then there was we used like the LB motor type, which drove down a cartridge, and now we've moved on to these things. These are called stepper motors, and they fit to a paddle inside the boiler. I'm going to talk about how you test these, how they work, and what you can do to repair them if they get stuck. So they look very similar on the bottom half of the body. This section here is pretty much the same, and they fit into the same paddle, but the difference is the motor itself. This one's a 24 volt motor. I don't know if it says it on there. Yeah, it does. 24 volt DC. This is a 240 volt motor. Yeah, 240 volt motor. So, you know, they can't be interchanged, and people have tried before in the past, and I've got a story about that. But anyway, so when you're testing these different motors, or when you're changing them, you've got to make sure the one you take off is the one you put back on, because one will be on the 240 volt side of the circuit board, this one, and this one will be on the low voltage side of the circuit board. So you test them differently and they work differently. A 24 volt motor with a 240 volt supply will probably blow the motor, and a 24 volt supply trying to move a 240 volt motor won't work. They will fit. This will fit on the same paddle as what this does. They have the same fitting. The paddle is the same, but they just won't work. I've got a bit of a diagram I've drawn, and I'll explain how it works and how you can test them. Right, so here's my artwork showing you the two different types of motor. We've got the 240 volt motor here, which is a 4-wire motor. This one, 24 volt motor DC. So this is low voltage, obviously. That's AC, mains voltage, DC, low voltage. This is a 6-wire. So on the 240 volt 4-wire motor, there's 4 connections to the circuit board, and obviously this is going to be on the mains voltage side. So there's two coils in this. So you've got 4 wires, black, blue, black, brown and purple. So you'll get 240 volts between the brown and the purple. So purple is your neutral, 240 volts is your brown, and the blue is your neutral, and the black is your 230 volts. But you won't get this, you'll only see this for a couple of seconds, so it'll be hard to test the voltage on this motor. So the best way of checking the motor really is, obviously you've got to be quick to get the voltage because it'll disappear. But dead test the coils, so knock the power off, pull the fuse out, make sure you're working safely, do your safe isolation test, and then you want to be testing each coil. So between the purple and the brown you should get 12.5 kilo ohms, and between the black and the blue you should get 12.5 kilo ohms. So that's just to check your coils, and if you can get the voltage, it's only going to be there for 2 seconds. So they're the tests you can do on that motor. Check the harnesses pushed in properly. You could have a, you know, always check your harnesses as well, because a lot of the time it's not the component which is at fault, it could be your harness. Check continuity through your harness, make sure it's a good connection on the motor, and yeah, that's how you check that one. This one is 6 wires. So the 2 left red connections are your 24 volt power connections from the circuit board. So if you test any of these, if you test red to neutral or red to earth, you'll get 24 volts on this one. And then the same again on this one. Test red to neutral or red to earth, you'll get 24 volts on this one. And then these 4 connections, the pink, the yellow, the blue and the black, these are your unipolar coils on your motor. And I've done this slightly wrong here. So what I've showed you here is, I've drawn it wrong, so I'm sorry. I'll show you how to do it properly. So between pink and yellow, when you're testing these together, this is a dead test again. So knock the power off, pull the fuse out, make sure it's dead, make sure you're working safely. Set your multimeter to ohms, and between pink and yellow, you should be getting around 484 ohms, around between, you know, 484, 500 ohms. And then same between blue and black. I've put it down as that, but it's wrong. Don't know why, my memory is not the same as it used to be. Between blue and black, you should get around about 480 to 500 ohms. When you're testing them singularly, you should be getting 242 ohms. So if I test between red and black, I should be getting 242 ohms. Red and blue, I should be getting 242 ohms. So it's half. It's half of when you're testing them together. So when you test them together, you should get 484. But when you're testing them singularly, you should get half of the resistance. So this one, red to yellow, 242. Red to pink, 242. And then together, that's when you should be getting the 484 ohms. So I've drawn that wrong, I'm sorry. Finding things at the moment. But I'll show you on my boiler. I'll show you how to do the test, so it should hopefully be clearer. These ones should be under warranty, to be honest with you, so you'll probably see more of these ones anyway. If you're out, you know, checking a motor, and these are on the oldest 2015 models, on the base models as well, so you might not come across these as much, and you don't really get many problems with them, but I just thought I'd show you how to test them anyway. I've done a picture now depicting on so if you're looking at the motor, if you're looking at it face on, you'll see the spindle on the motor. So you know, when the spindle's down or when the spindle's up, it shows you what position the paddle will be behind it. So when the spindle's up and it's driven up, what happens is, as it's driving up, it moves the paddle down because it's on like an axis. So as the paddle's driven the spindle's driving up, it's moving the paddle down, which is blocking off the central heat and return, which then creates a circuit for the hot water. So coming back from the plate heat exchanger back to the main heat exchanger. So as your as it's driving, pulling the spindle up, it's pushing the paddle down. I'm sorry, it's hard to explain. So yeah, so it's blocking off the central heat and return, so it's in hot water mode, so you're getting a flow from the plate heat exchanger back to the primary heat exchanger. And then oppositely, once it's driving down, it's lifting the paddle up, which is blocking off the hot water port and giving a circuit to the central heat and return back to the main heat exchanger. So if you're looking at it, you can see what position the motor and paddle's in, what the diverter valve is in. So if it's down, it's in central heating mode because it's blocking off the hot water. It's like, you know, it's moving up and down, so in the opposite direction. So if it's down, the paddle's up, blocking off the hot water. And if it's up, the paddle's down, blocking off the central heater. So yeah, I know it's difficult. I'm not getting the information across in my brain, and I know what to say, I just can't say it. So yeah, I think drawing it in a picture, hopefully, you know, hopefully helps what I'm trying to say. I'm probably not going to do many more of these. This is, I know what I'm trying to say, I just can't say it. But yeah, if you look at that picture, that's what I'm trying to say. And again, I'll try to show you in on my boiler how it works. Okay, thank you very much. So here we are. This is the connection on the circuit board. It's hard to see. There we go. That's a good. You can see we've got 6 connections. We've got the black, the blue, the yellow, the pink, and the 2 reds. So there are 6 connections on the low voltage side of the PCB. That's the high voltage side. You can see connections are a bit larger, and also the harness cables, the thicker the cables. That just shows you it's the high voltage side. These connections are smaller and the harness cables are thinner. This is the low voltage side, and as you can see by the head on the motor, that's the 24-volt motor. Like I said, this is the one with 6 connections. On my multimeter, I've got it set to ohms, and I'm just going to show you how to test the coils. So so what I'll do, I'll show you the fire 2 connections. These 2 here, these are the power connections to the motor. So these are both 24-volt supply. This left connection supplies these 2 here, and this right connection supplies these far 2 here. So if we were to test single connections on the coil, we'd go from this one to any of these 2, and then we go from this one to any of the far 2. I'll set it up now, and I'll show you a single test and then testing them together. Here we go. So I've got it on the right connector on the 24-volt supply, and I'm testing the single black power to the coil, and we're getting 253 ohms. That's same, you'll get roughly around the same across the one next to it, the blue one. but then I'll test them together and you should get double that. So if I'm going to test them both together, you should get 250 times 2, which is around 500. So I'll just set that up now. There you go, 500. It's 0.501 kiloohms. So kiloohms is 1,000 ohms, but it's saying it's half of 1,000 ohms. My multimeter is a strange one. I don't have my ideal one anymore. I've got this one. Got this one. It's a proper Fluke multimeter, but it's a Chinese version of a Fluke multimeter sold in China only. So that's why it looks a bit different, but it's saying 500 ohms, even though it's got the K there. I'm on the two together, as you can see. That would be the same for the other two. I'll put them on them two. And again, we're getting 496, which, you know, is close enough. I'll just show you how to test the power voltage to them now. So just give me one moment and I'll set that up. So if you can see here, I'm on voltage DC. Because I've only got the one hand to hold the camera, and to show you this test, I've had to jam my one probe of my multimeter on the earth strap of the boiler. You'd normally use a neutral or an earth on the incoming supply, but they're too far apart for me to hold with both of my hands. So I have my positive red probe on the 24 volt supply on the circuit board, and which are these two here, and then obviously I've had to just jam the earth on there to show you, and as you can see, we're getting 25 volts. If I just change it to the other one, so there's two, I'll put it on this one, again you'll see there's 25 volts. That should always be there. You should always be getting that from the circuit board. That's sending power to the motor, to the coils. So you know, whichever one, if you want hot water or heating, then obviously the circuit board will move whichever coil is in series and move the paddle up or down. It's obviously difficult to show you how to do that with one hand, and I can only show you the 24 volt motor. I can't show you the 240 volt motor because I don't have it here with me. Obviously this is a newer model boiler. It's got the ERP pump. So yeah, hopefully this helps. I mean, I'm trying my best. Sometimes it's difficult to show. I don't know if you can see that little green flashing light there on the pump. That's an indicator light to tell you if the pump's running, or if it's running fast, or how fast it's running. If it'll flash, if there's a problem with the pump, that's just an indicator to tell you if the pump's running or not, if it knocks the power off. See, the light goes off on the pump. That's just a new thing that they've put on these pumps. This is a test pump. I've had this pump for quite a long time now. These are on all boilers now, but this was just a test to see if it actually worked or not. Obviously you can see the test pump, but it's still on my boiler. And but now we run tests. Well, not we, I don't work for them anymore, but do run tests on new components, on field trials. But this light is on all pumps now, I believe, and just so, because obviously it's hard to tell whether your pump's running or not. This, depending on the flash and the status of the pump, that's just a light to indicate whether running at full speed, half speed, or if it's working at all. So that's just another little thing for you. Okay, again, appreciate this isn't the best information. It's hard for me to make these now, but I'm bored at home, so I need something to do. So I hope you find this helpful, and I'll try and make more if I can. Thank you very much. Bye-bye.